Okay, so here we go. Paper 2 of mid-year exam 2025. First one, draw each line. Draw a line between each term and the correct example. Okay, base quantity, electric current, base unit, kilograms, derived quantity, force. Force is a quantity. Derived unit, coulombs. Coulomb. Coulomb is a unit of electric charge. A set of experimental measurements is described as precise and not accurate. Then we have the next one. Calculate the percentage uncertainty of V. Okay, so V can be made the subject. V square equals to F multiplied by R divided by M. And then we can take square root on both sides. And square root means raised to the power 1 over 2. Or you can write square root also. Doesn't make any difference. We need to find the percentage uncertainty. All the percentages are given already. The percentage of F is 3. So 3% plus percentage of R is 5%. 5% plus percentage of mass is 4% plus what do we get? 5 plus 3 8 plus 4 12, and then whatever the final percentage is, we multiply that percent by the exponent. Exponent is 1 over 2. So multiply by 1 over 2. So you're left with 6%. So very popular question, nothing new. A very standard question. Common mistake is students forget the power. They add the percentages, all these percentages, but they forget to deal with the power. Anyway, let's move on to the next one. The value V is 15.0. Calculate the absolute uncertainty in V. Okay, so we need to find 6% of 15.0. Multiply by 6 divided by 100. And I'll write this one on the calculator. So the next one we have is define momentum. So momentum is simply defined as product of mass and velocity. It's probably the easiest mark. Okay, let's move on to the next one. We have the sphere X and the sphere Y. They'll be colliding with each other, as you can see, and the force that they exert, the force that Fi exerts on the ball Y, force on the ball Y by the ball X is given. And I also know one thing, that the force exerted by the ball Y on the ball X, so means force exerted on X by ball Y should be equal and opposite according to Newton's third law of motion. But the very first question is, we need to calculate the kinetic energy of X before the collision. Okay, so first thing is we write down the formula 1 over 2 mv squared. The formula must be written. So 1 over 2 means 0.5. Let's check out the value of mass of the ball X. Okay, 0.24. So before the collision, what is the velocity? 2.3. probably the easiest question. And let's see if everything is fine. Kilograms, yes, 2.3. And we take square of it. So what we get is 0.63 joules as it is. We write this one as it is on the calculator. So in the next one, the area enclosed by the line, enclosed by the lines and the time axis in figure 2.2 represents the change in momentum of the ball during the collision. So area of the graph means the change of momentum of the ball y during the collision. Calculate the magnitude. Okay, so we need to find delta p, change in momentum of the ball y, and that equals to the area under the area enclosed by the lines and the time axis. So it should be an easy one. We need to figure out the shape, and the shape is that we have two triangles. The first one would be 1 over 2 base into height. Base is 3, but 3 millisecond. 3 millisecond means 0.003 or 3 into 10 is power minus 3 times 200. So if we make a scale, it would be 200 and 20, 40. So one line is representing 20. How do I know? 400 minus 200 divided by the small blocks. How many blocks do we have? 10. So 200 divided by 10 means 20. So one block is representing 20. So this one would be 220 and then this one would be 240. So multiply by 240, 1 over 2, base is 3 into 10 power minus 3 and height is 240 plus, let's take a look at the other triangle. For the other triangle, 1 over 2 base, 1 over 2 as it is, from 3 to 5, the base is 2, means 0.002, multiply by 240 for that one as well. So plus 0. This one multiply by from 3 to 5 is 0.002 seconds, or 2 into 10 is power minus 3. Height is same. So I'm going to write all of it as it is on the calculator. Let's take a look at the next one. Calculate the magnitude of the velocity of the ball y after the collision. So we have change in momentum of y. So we do have the value of change in momentum of y. Okay, so I'm not writing the subscript because we are referring to the ball y. So I can write at the top, everything I'm writing is for the ball y. So for the ball y, delta p equals to m into v minus u, or mv minus mu, same thing. Now what is the value of change in momentum? We found it already, 0.60. So 0.60 is the value of the change in momentum divided by mass. Mass was given as how much? The ball y, 0.12 divided by 0.12, that's the value of mass, and On the right side, you are left with v minus u. So this is what you have on the right side. V minus u means final velocity minus the initial velocity. So you need to find the final velocity after the collision. But what is the initial velocity? Let me divide this one first. 0.6 divided by 0.12. We get 5. 5 equals to v minus u. So v minus, now what is the initial velocity? Initial velocity is, as you can see over here, 2.3, but it's on the left side. According to the sign convention, should be negative. So the value of u is also negative. So minus 2.3. This negative sign because of the formula, the other negative sign because of the sign convention. Momentum is always solved by sign convention. V plus 2.3, and then v goes to 5 minus 2.3, and that should be 2.7. So 2.7 meters per second is the final velocity. The most important thing, I should put a star over here and the star with the formula that the change in momentum is solved, or the question of momentum is solved by sign convention. But if you don't follow the sign convention, you should be getting at least 1 mark. Okay, now we need to sketch the force Fx, which is a force exerted on the ball x by the ball y. So what did I say? It should be exactly the same. These two forces should be exactly the same, and opposite means with the reverse sign. So force Fi is positive, Fx should be negative, and the value magnitude should be same. So 240 at 3. So this one is 200, 220, 240. So a straight line up till here, and then so exactly the flipped image, because the force Fy is equal to the force x in magnitude but opposite in direction. So easiest 3 marks that were there in your syllabus for a question of graph. Usually the question of graph is very tricky, in which you have to at least sketch the graph. Sketch the graph is not an easy one, to be honest, but this one was probably the easiest one. So just copy paste them from the notes. Also, we have done this one several times. Calculate the vertical component of the force exerted by the bar on the beam. Okay, force exerted by the bar on the beam. This is a force exerted by the bar on the beam. I can also draw it over here, the same force, 33 Newton, and the angle, this angle would remain the same, 52. Okay, just for convenience, I've drawn the force over there. The point of application of force is same. The force is being applied at the point B. It is 33 Newton, and the angle with the horizontal is 52. Now the direction of force is top right corner. So one component would be to the top, one component would be to the right. The vertical one would be 33 sine 52, because this component is not connected with the given angle. So it should be 33 sine 52, and the other one should be 33 cos 52. So we need to find the vertical 33 sine 52, which should be into SF26. Take moments about A, calculate weight of the beam. Okay, so weight of the W needs to be found out. So if I draw an easier diagram, we have a bar here. This is a point A. You can think about it as a pivot. One vertical force is weight W, and since it's a uniform beam, so weight should be exactly in the middle, which is the total is 0.3 plus 1 0.4, so weight should be at 0.2 meters. The other force is this one that we just found out at a distance of 0.3. How much is it? 26 Newton. And there's a force at the end, force of the bucket, which is 12 Newton. So 12 Newton, that one is at a total distance of 0.4. Now let's label the clockwise ones and anti-clockwise one. So downward, this one clockwise, this one clockwise, and 26 would be anti-clockwise. So clockwise on one side 0.4 Newton, multiply the perpendicular distance is 0.2, plus the other one clockwise is 12. 12 multiplied by total distance is 0.4. This one was 0.4 newtons. Oh, sorry. The first one is W. The force was W. Unknown. The one that needs to be found out. This one is W. Equals to the anti-clockwise one, 26 multiplied by the distance 0.3. So 12 multiplied by 0.4, and we have W multiplied by 0. If you do it on the calculator, the final answer in 2SF we get is 15. Okay, you can do the calculation from here onwards, or just write this thing on the calculator all at once. This one would be subtracted and 0.2 will be divided, and that would be the value of the weight W. So Young modulus, the formula of Young modulus, one of the formula is stress divided by the strain. It means stress equals to Young modulus multiplied by strain. Okay, I'm using the symbols. We have the symbols are there as it is in the notes also. 2.0 into 10 raised power 11, that's the Young modulus, multiplied by strain is given 7.5. Strain is without any unit, by the way. 2.0 into 10 raised power 11 multiplied by 7.5 into 10 raised power minus 4. We get 1.5 into 10 raised power 1, 2, 3, 4, 5, 6, 7, 8. 1.5 into 10 raised power 8. Okay, the next one we need to find the diameter. Okay, now we have the stress also. So stress equals to force divided by area. This is the last question. Force divided by area. So stress equals to force divided by area. Since it is the cross-sectional area and it is the cross-section area is the area of a circle in this case, and the area of the circle is pi r square. So you can find the radius and then multiply by 2. I'll just keep it easy. So diameter equals to force, which equals to stress equals to force, and the stress is given as 1.5 into 10 power 8. Force is given as 78, the weight of the object, divided by pi times r square. So r square equals to 78 divided by pi as it is 1.5 into 10 raised power 8. And then you take square root of it. So I'll do it directly on the calculator, or you can also write it as 8.1 into 10 raised power minus 4. So this is a question we have done it already, but let's go through it anyway. Show that the time taken for the arrow to reach the target is 1.08 seconds. So this is a projectile motion. You're provided with this velocity, initial velocity at a certain angle, at an angle of 4.3 degrees. Let us draw the two components. So since the velocity in the top right corner, so one component would be to the top, one component would be to the right. So 65, since this one is 65 meter per second, so the one touching the angle would be 65 cos 4.3, the other one would be 65 sine 4.3. Okay, time to reach the target. We know the horizontal displacement also, so we can use for the horizontal motion, for which we have a single equation. Displacement equals to velocity into time, or time equals to displacement over velocity. Displacement equals to 70 divided by speed. The horizontal one is given as 65 cos 4.3. Whatever the answer of this thing is, 65 cos 4.3. This one would be your value of time, which should be 1.08. Calculate the height of the center of the target above the ground. Okay, so we need to calculate this height. What we can do is we can calculate the height of the projectile. So height of the projectile from its starting point, so in order to calculate the height of the projectile which hits the center of the target, we'll have to use a vertical motion. So let's go with this one. S equals to ut plus 1 over 2 at square. So displacement needs to be found out. Initial vertical, so we are using the vertical motion only. We're considering the vertical motion only. In the vertical motion, the initial velocity is 65 sine 4.3. 65 sine 4.3, which is 4.87. The value of time is 1.08 plus 0.5, 1 over 2 as it is, means 0.5. The value of g, 9.81 for vertical. When we use equations of motion, we always take 9.81 times 1.08 square. So this is the displacement, vertical displacement, and this is also the height. So if you hit it on the calculator, you get minus 0.46. Minus means it's below the starting point. So from this starting point is below the starting point, means this one is now known as 0.46 meters. Minus simply means it's below the starting point. In sign convention, minus means below the starting point. So we know this one 0.46, and we know the total is also given. The total is given as 1.66 meters, and we need to find this one. This one needs to be found out. Let's call it x. So x equals to 1.66 minus the total minus the one at the top. This is the total. If you subtract this distance from the total, you'll get the leftover, which would be 1.2 meters. By considering the energy changes state, I explain how the final kinetic energy of the arrow as it hits the target with its initial kinetic energy after it is released. Okay, so initially the arrow was someplace over here at a larger height. Then it goes to hit the target and probably lands over here, for example. So initially it was having larger GP, and now at this point the GP is decreased because the height is reduced. GP is decreased, it means kinetic energy must have been increased because the total energy always remains constant. So since GPE decreases, it implies kinetic energy must increase to conserve the energy law unless acted upon by a resultant force. An object at rest stays at rest. An object moving with uniform velocity keeps moving with uniform velocity unless acted upon by a resultant force. So this thing is really important. If you miss resultant force, you're not going to get mark here. Don't say external. That would be incorrect. You need to use the word unless acted upon by resultant force. So one of the forces given, which is the total resistive force R, it says state the name of other two forces acting on the box. So one is vertically downward, which is weight, and one is perpendicular to the surface of the block, which is normal contact force. So vertically downward weight, so for direction we need to be very careful. You cannot say up, down, left, right because the plane is tilted. So we have to refer according to the plane. Use data from figure 5.2 to show the acceleration of the box is 2.6 meter per second square. Okay, so we need to find the acceleration, and it has uniform acceleration because the graph is a straight line. So we can find the acceleration. This point is 2.0 and 6.0 coordinates, and this one is 0.5 against 2. Yeah, it seems like 0.5 against 2. No, it's not 0.5. It's not exactly in the middle. So I can instead use the first one, 0, and this one is a 0 against 2, 4, 6, 8. So gradient would be equal to the, what do you call that, acceleration. So y2 minus y1 over x2 minus x1. At the top we get 5.2 divided by 2. So basically half of 5.2, which would be 2.6. So the acceleration equals to the gradient. You must write in the question over here that acceleration equals to gradient of that graph. So the examiner should know that you know at least this point. Okay, the next one is calculate the resultant force acting on the box. So resultant force equals to mass times the acceleration, and mass is given as, mass was given someplace over here, 65. Mass of the block is 65. So probably the easiest question, 65 times 2.6, you get the resultant force, which is in this case is 169. Okay, let's move on to the next one. Determine the resistive force R on the box. Okay, so the box is sliding downward. It means the resistive force is up the slope. Box is moving down the slope, so the resistive force is up the slope. And we can resolve the weight into components like we always do in these kind of questions. So the one down the slope would be W sine theta, and this one would be W cos theta, or you can call it mg sine theta or mg cos theta. Now let's talk about this direction. So the resultant force would be downward force W sine theta or mg sine theta minus the upward force. So what is the resultant force? 169. What is the force down the slope? W sine theta or mg sine theta? Same thing, because W equals to mg. 65 times 9.81 times sine 20 minus R. Then you can make R the subject. So R would be this whole thing minus 169, which in this case would be 49. So we have done this case several times. Whenever the object is placed on the inclined plane, how do we find the resultant force? The force down the slope is always mg sine theta if this angle is given. angle of slope is given. Yeah, I hope this one can be done. Okay, complete the figure. All right. Acceleration is vector, force is vector, energy is scalar, momentum vector, power is scalar, work is scalar. So three momentum and the rest are scalar. So that the weight of the sphere is 41. Okay. Show that the weight of the sphere is 41. Okay. So what we know is density is given, the radius of the sphere is given. So we can find the mass using the formula mass equals to density times volume. And once we find mass, we can use the formula W equals to mg. So mass equals to density times volume, 0.23 meters, and volume of a sphere, the formula is 4 over 3 pi r cube. So this is the value of mass. So you use the value of mass and multiply it by 9.81. Whatever the answer of this one is, you multiply this answer by the value of g, which is 9.81. The weight would be into SF41. The tension in the cable is 290. Determine the upthrust acting on the sphere. So tension is given and you need to find the upthrust. So tension, upthrust is always vertically upward. So you need to find this force, the upthrust. But we don't have the value of the force vertically downward. So the tension is slightly in the bottom left corner. Tension is always towards the point of connection of the object with the surface. So tension is downward here. Not vertically downward, but in the bottom left corner something. If we draw the two components of this tension, then we know these two angles will be equal. This angle would also be 75 degrees. Now the component connected with the angle would be with the cos. Component not connected with the angle would be with the sine. So tension is given as 290. So this one would be 290 times sine 75. 280. This one is 280 Newton. So one of the force downward is a component of tension. I should write here. Upward forces over here. Since it is at rest, so upward forces will be equal to the downward forces. So the only upward force is upthrust. But downward, we have two forces. One of them is T sine 75, which was 280 Newton. Another vertically downward force is the weight of the sphere, which is 41. The two forces are vertically downward and the object is in equilibrium. The sphere is in equilibrium. It means upward forces equal downward forces. So the upward forces upthrust equals to 280 plus the other one downward force, which is 41. So you get 321, or you can write in 2SF as 320. Both should be acceptable. State what is meant by work done. Product of force and displacement in the direction of force. Product of force and displacement in the direction of force. Okay, then we have this situation. I'll try to solve this one quickly. The acceleration of the lift between 0 and 3 seconds. So basically you need to find the acceleration using the velocity time graph, and that should be equal to the gradient of this graph. So you can find the gradient of this graph. This one would be 2.1234. So the rise is 2.4 and the run is 3. So I can use the shortcut rise over run. Gradient equals to rise divided by run, and this one would be 0. All right, let's move on to the next one quickly. We have 5 minutes. The work done on the motor to raise a lift between, okay, work done needs to be found out. Work done between 3 and 6 seconds. All right, let's talk about the total force. In order to find the force, one of the forces vertically downward, which is the weight of this elevator, 13,000 Newton, and it's moving upward, so the frictional force would also be downward. You see, it's moving upward, velocity is upward, so the frictional force is there downward, which is 2 kilonewton. So what is the total force which would be there acting on the block is 15 kilonewton. So the motor has to apply the force of 15,000 Newton. 13,000 Newton because of the weight, 2,000 Newton because of the air resistance. So 15,000 times 7.2. 108 000. Or into, you can also write into SF11 followed by 4 zeros. Should be same. Both should be acceptable. Okay, the last one, motor has efficiency 67%. Tension in the cable is this much. Find the input power. Input power equals to force times product of force and speed. So at a time of 2.5, so 2.5 is exactly in the middle of 2 and 3, where the speed is exactly 2 meter per second. So the speed is 2 meter per second. at a time of 2 seconds. So P equals to F force times the speed. So F is given as 1.6 into 10 raised power 4. The speed is given as 2. The motor has efficiency of 67%. The tension in the cable. So we need to find the input power to the motor at this time. So we'll find this power, the total power, and then we can find 67% of that power. So let me find this one quickly. 1.6 into 10,000 multiply by 2. 32,000 watts. Okay, this one is 32,000 watts. So the situation is the motor is getting or is supplying a power of 32,000 watt to the elevator. The motor is supplying this much. How much power should the motor be getting originally? So motor is wasting a lot of it, and after wasting like 33% of the power, the leftover is this one. So this is the output one, which is 33% of the power is, I'm writing percentage here and power here. So 33%, because motor has efficiency of 67. Motor has efficiency of 67. So 67% of the original power is 32,000 watts. 67%. 67% is how much? 32,000. What would be the original? The total would be X. Or you can also use the formula of power efficiency. Percentage efficiency equals to P out divided by P in multiply by 100. This one is given as 67. Out is 32000. In is, we don't know, multiply by 100. So input would be 3200 multiplied by 100 divided by 67. 47761 or 48,000. So explain whether the increase in gravitational potential energy of the lift from time 0 to 7 is less than, same or greater than the work done by the motor. A calculation is not required. So some of the work is done against the friction also. So the gravitational potential energy is less than the work done by motor. So due to the work, some of the work done against friction, the GPE is less than the work done by the motor.